Any communication system needs both a sender and a receiver. The sender encodes a message and does work to propagate it. The receiver intercepts the energy and decodes the message. In the case of sound communication, the receiver hears the message. In vision, specialized cells, called photoreceptors, are responsible for intercepting light energy and transducing it into a form the brain can comprehend. The photoreceptor cell intercepts light energy with a modified cilium. In hearing, specialized cells, known as hair cells, perform a similar function for sound energy. Remarkably, hair cells also use a modified cilium to intercept sound. Hair cells have a curious property. They respond mainly to amplitude of sound. They do not respond to that other property of sound, wavelength, that can carry information. To be able to respond to frequency requires assemblages of hair cells. This makes hearing ultimately a social phenomenon. Many hair cells, each capable of responding to a particular frequency, can encode a frequency spectrum by dividing it up between them. This is known as the xylophone model for frequency discrimination. You'll see what I mean. Vision requires photoreceptors to be embedded in larger structures called eyes that can optically manipulate light. Hearing also requires hair cells to be embedded in larger structures called ears that can acoustically manipulate sound. There are a lot of dimensions to this, and it is one of the reasons why ears are so complex in structure and function. Key to understanding this is the mysterious concept of impedance. We've mentioned this briefly in the biomechanics module of this course. We return to impedance in earnest here. As you watch the videos to follow, I want you to keep three things in mind. First, what is it about undulopodia that makes them such versatile sensory cells? There's no good answer to this. I just want you to be thinking about it, and maybe you'll want to look more deeply into it. Second, what are the physical limitations that hair cells must overcome to be able to transduce sound? How do these limitations shape organs of hearing? And third, I want you to reflect on the nature of impedance, which governs transient flows of energy through systems, like sound energy through ears.